Welcome back everybody. So let's just continue with the questions that we have started. So this is the next question in the sequence. So this question belongs to the topic logarithm and their properties. So the question states so first the definition of two operators sigma and pi is given, because if you don't understand the operators itself, then how would you calculate this expression? So let's first understand the operators first. So first operator is sigma operator. So this is the symbol for sigma operator, and we have a variable which is ranging from n equals to 1 to m, and this is the expression a n. So n is the subscript and the variable in this expression. So what we do is we start from n equals 1 and we write 1 in place of n, so we get a1. Then we have to introduce a plus sign and we have to increment the value of n. So next value of n becomes n equals 2. So we write a2, and then similarly we write a3, and this continues till the situation when n equals m and the final value becomes am. Okay. So a similar relation or a similar operator is called the pi operator. Pi operator, just like sigma, has the variable n equals 1, which is ranging from n equals 1 to m, and an is our expression. So how would we open it? So first of all, check where is n starting from. N is starting from 1. So we write the first term a1, 1 in place of n. Then we increment and write the next value of n, which is equals to 2. So the next value becomes a subscript 2. Similarly, the subsequent value becomes a subscript 3, and this continues till the situation where n equals to the final value. Final value is m, so the final value becomes a to the subscript m. So this is how this expression is expanded or written. So now we are given in the question this crazy looking expression, and then we have to solve for n in this expression. Okay, so let's do step by step. So since this looks like a big expression, so let's write step 1 first. This is our answer. So let's write step 1. Step 1 would be simplify the left hand side. So what we would be doing here is, first we would try to simplify the left hand side, then we will try to simplify the right hand side, and finally we will equate both to find what is the value of n that satisfies this final equation. Okay, so let's simplify the left hand side first of all. So left hand side is equal to sigma r equal 0. R is the variable over here, and it is varying till the final value of r would be n minus 1. Then we have log 2, and inside log we have r plus 2 over r plus 1. So let's try to expand it. Okay, so first we write log 2. Instead of r, what we would do is we would start with the initial value of r equals 0, and put it here. Okay, so it's 0 plus 2 divided by 0 plus 1. Okay, so what does the definition of sigma says? Now we have to introduce a plus sign, and finally we have to write the function again, log 2. Now what we are going to do now is we have to increment the value of r. So next value of r after 0 is 1. So we write 1 over here plus 2 divided by 1 plus 1, and this continues. So let's put dot 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 over here, because obviously we are not going to write all the values, and let's try to write the final value, log 2. So the final value would be r equals n minus 1. So instead of r, you have to write n minus 1 over here, n minus 1 and plus 2, which is coming from the expression, and n minus 1 at the denominator as well, and plus 1. So this is how the left hand side has expanded. So let's try to simplify it a bit. Log 2, this becomes 2 by 1, and we have another log 2, this becomes 3 by 2. Okay, and then we have finally log 2, this becomes n plus 1 divided by n. Now as we know, uh, log a, we have to remember a property. Log base can be n, base a plus log base b. So this property does not depends upon base or anything like that. So log base a plus log base b is log base a into b. So we would be using this property over here to simplify our expression. So LHS is equal to log 2. So this is 2 upon 1 into this is 3 upon 2, and this property will ensure that this multiplication happens till the very end. Okay. So let me explain it for you guys. See, this log base a plus log base b is not restricted to only two values. You can put another value log base c as well over here. Let me write log base c, and that value will just go in multiplication of these values. So we can add n number of terms and all the sums end up in the product. So this is what we have done. Okay, so LHS is equal to log 2, and we can identify a pattern over here. So 2 upon 2 is cancelling. If you try to write the third term will be 4 upon 3. So 2 upon 1, 3 upon 2, 4 upon 3. If we try to write, and we can see that this 3 and 3 is also cancelled. So we have identified the pattern now. So this 4 will also be cancelled, and this n will also be cancelled. Okay, so finally we would be left with n plus 1. So this is the small expression that our large expression has boiled down to. Okay, so let's keep it. So let's keep it with us and try to simplify the right hand side. So let's go for step 2. Step 2 would be, okay, let me align first. Simplify the right hand side, RHS. So RHS is, okay, let me write the RHS. It's pi upon pi, variable r, which starts with the value of 10, goes till 99, and we have log r upon r plus 1. Okay, so this is our right hand expression. So we will try to simplify this. So let's try to expand the pi exponent. Okay, so we write log, then r is starting from 10 this time, so we'll write 10 over here, and 10 plus 1 as well over here. Then okay, oh, this is a pi now, so we have to multiply. So next value log 10, it will be not log 10, wait, the value is r over here, so the next value will be r equals 11. So log to the base of 11, and over here also the next value will be 11 plus 1. Okay, so let's write one more value. Log, we have taken 10, we have taken 11, the next value will be log 12, and over here will be 12 plus 1. And finally this multiplication will go on until r is equal to 99. So let's write the final value. Log r is 99 in the final value, so final value is 99 over here, and it's 99 plus 1. Okay, now let's try to simplify what we have got after expanding. So log 10, this is 11, log into log 11, by 12 into log 12 by 13, and this continues till log 99 to 100. Okay, now we would be so this is our RHS. Now we could simplify this a little more, because we can see that the base of every term, so base over here is 10 of log, and the base over here is 11 of this function, and the base over here is 12. So base is changing. So let's try to simplify it by writing each term in a common base, and common base, let's take it 10. Okay, so this is still log 10 11. So this we have to write in base 10. Do you guys remember it? Okay, let me write the property for you guys. So let's write over here. We know that log base a of b is equal to, okay, it's b, let me make it correct. Okay, if it is equal to, what we have to do is we write it in log 10. First we write log 10 over here, and then we divide it by the expression log 10a. So this is the property of converting a log which is in logarithm, which is in base a, to the log which is in base 10. So this is the property. So how would we convert this? Log, first we have to write 10, then this 12 input value divided by log, then we write 10 is our base, and then we have to write this, 11, okay, our original base, and we continue it for every value. So this value becomes log 10 into the input value of 13 divided by log 10 upon the original base of 12. So this will continue, and let's write down the final value. Log, this is 99 to 100, so let's write it first, log 10 to the input value of 100 divided by log 10 and our original base, that's 99. So what we are gonna do is, do you guys see it? See, this term and this term is same, this term and this term is same, so let's cancel these terms. So this term is cancelling with this term is cancelling with this, and if we continue the pattern, this term will cancel with this, and finally log 10 by 99 will also get cancelled if we continue to follow the pattern, and we would be left with only one term, which is log 10 to the input value of 100. So this is RHS. Okay, so RHS, so we can rewrite this as log 10 whole square. So RHS is equal to 2 times of log 10 to 10. Since we know log a upon a, log a and the input value is also a, this value is equal to 1. So this entire thing, the value of this entire thing is 1. So it's 2 into 1. This is RHS. Okay. So now what we are going to do is, since we have let's go for step 3. Since we have calculated LHS and RHS separately, so we are going to do is LHS equals RHS. This was given to us in the question. Given to us. Let's write the simplified values. See, this was our LHS, this was our RHS, and equality was given to us in the question. And now we will write the simplified value of LHS, which was log 2. Let me write. It is log 2 n plus 1 is equal to 2. Okay. So this log 2 could go over there and become, okay, this expression can be reduced to this expression. Okay. So this expression and this expression are reducible to each other because of the definition of log itself. So how log is defined? So let me write that again. So log a b is same, log a b if is equal to c is same as b is equal to a to the power c. So this comes from the definition itself of the logarithms. So n equals 4, 2 square is 4 minus 1, which is equal to 3.